Alright, this is the quiz review. Remember, you can pause it at any time, rewind it, and listen to it again. For each scenario, write linear increase, linear decrease, exponential growth, or exponential decay. Laurel grows 1 inch each month. Alright, so she's growing 1 inch. That's a constant amount each month. So that is linear. And since she's growing, it's going up. So that is linear increase. Okay. Number 2. Luke sleeps 5% more each day during the stay-at-home order. 5% is not constant because a percent depends on how much you actually had to start with. So percent is going to be exponential. And it's more, so that's exponential growth. Number 3, Josh loses 8% of his sanity each day having to be with his family 24/7 during the stay-at-home order. So he loses 8% each day. So 8%, that's going to be exponential again. And he's losing it, so that's exponential decay. And number 4, Mrs. Williams takes 2 points off for each late assignment. So 2 points is constant, and I'm taking them off, so it's going down. So that is linear decrease. Okay. Use this information for questions 5 through 6. Susie had a starting pay of $15,000 annually. Her salary increased 10% per year for 10 years. How much will she have at the end of 10 years? How long will it take her to make over $25,000? So first thing you want to do is write a y equals 15,000 parentheses because it's 10%, so it's exponential. 1, it increased, that's a plus, 0.10 to the t. How much will she have at the end of 10 years? Well, 10 years is time, so that gets plugged in for t. So it'd be 15,000, 1.10 to the 10th power, and you put that just on the main screen in your calculator. 15,000, 1.10 10th power. So she'll have 38,906 and 14 cents. How long will it take her to make over $25,000? You cannot plug 25,000 in for t, it's not a time. That's going to be what we're trying to find out how much she makes over. So you're going to have to use the y equals. You're going to have to go to y equals. And I'm not using the 10. This was a separate question. I'm using the original formula. 15,000, 1.10 to the x. Make sure you have an x in there. Then you go to second window, and we'll tell it to start at 1 for 1 year. And this is the years, and this is her money, and we want her to make over 25,000. So if you look over here, she makes over 25,000 in 6 years. Alright. The population of spores after X number of hours is modeled by the expression 500.87 to the X. What is the rate of decay of the population of spores? Your rate comes from the parentheses. Remember, 500 is your starting value. So you have to take 0.87 and you have to subtract 1. So 0.87 minus 1 gives you 0.13, which is 13%. Write a function rule to model this situation. A $52,000 car decreased in value by 10.5% each year. So y equals, your starting value is 52,000. It's got a percent, so you're going to use parentheses, 1. And this one decreased, so you're going to subtract. And then remember, you have to move your decimal 2 places, so it becomes 0.105 to the t. Okay? You can simplify that. So if you do 1 minus 0.105, you get 0.895. So this is 52,000.895 to the t. All right, please email me if you have any questions.